FastMCP implements OpenTelemetry instrumentation through context managers that create nested spans for fine-grained operation tracing. The framework's tracer integration allows developers to instrument custom operations while maintaining automatic span hierarchy and attribute propagation. We'll examine how the getTracer function initializes span contexts and how start_as_current_span establishes parent-child relationships between operations. The code demonstrates setting custom attributes on spans to capture operation-specific metrics like input length and data counts. From FastMCP, import FastMCP. From FastMCP Telemetry, import getTracer. MCP equals FastMCP, custom spans. At MCP, tool. Async def complex operation input, SDR. Tracer equals getTracer. With tracer, start as current span parse input as span. Span set attribute input, length, len input. Parsed equals parse input. With tracer, start as current span process data as span. Span set attribute data, count, len parsed. Result equals process parsed. Return result. This code demonstrates how to create custom spans within FastMCP tools using OpenTelemetry APIs for fine-grained observability. The pattern shows explicit instrumentation of suboperations within a tool function, complementing FastMCP's automatic tracing of top-level operations. The implementation uses FastMCP's getTracer to access the configured tracer, then creates nested spans for parse input and process data operations using context managers. Each span captures relevant attributes like input length and data count, providing detailed telemetry beyond what FastMCP automatically generates. This approach maintains the automatic tool registration benefits while adding custom instrumentation where needed. The trade-off here is between observability granularity and code complexity. While FastMCP automatically traces tool execution, custom spans add overhead but enable precise performance monitoring of internal operations. This pattern is particularly valuable for complex tools where understanding suboperation timing and attributes is important for debugging or optimization. Let's break it down. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, which provides the core functionality for implementing Model Context Protocol (MCP) servers. This class serves as the foundation for creating FastMCP 2 server instances, though this line alone doesn't create any instance or configure any behavior. From FastMCP Telemetry, import getTracer. Imports the getTracer function from the FastMCP Telemetry module, which provides tracing functionality for monitoring and observability in FastMCP applications. MCP equals FastMCP, custom spans. Creates an instance of FastMCP with the server identifier, custom spans. The string parameter serves as a label for identification in MCP protocol handshakes, allowing clients to recognize this specific server instance. This line initializes the MCP protocol implementation with the given identifier, but doesn't configure any functional behavior. At MCP, tool. Async def complex operation input, SDR. Defines an asynchronous function named complex operation that takes a string input and returns a string, decorated with @MCP, tool, to register it as a tool in the FastMCP framework. The decorator automatically handles tool registration using the function's name, parameters, and type annotations for schema generation and validation. Tracer equals getTracer. Calls getTracer and assigns the return tracer object to the variable tracer. This retrieves a tracing instance for monitoring and instrumentation purposes, though the specific tracer implementation isn't visible in this line.
With tracer, start as current span parse input as span. Span set attribute input, length, len input. Parsed equals parse input.
Starts a new tracing span named parse input using the tracer's context manager. Within this span, it records the length of the input as an attribute named input length, then calls the parse function with the input and stores the result in the variable parsed. The span automatically closes when the block exits, capturing the duration and any attributes set during parsing.
With tracer, start as current span process data as span. Span set attribute data, count, len parsed.
Starts a new tracing span named process data using the tracer's context manager, then sets a custom attribute data count on that span with the value being the length of the parsed collection. This creates a structured trace point that captures both the operation name and a metric about the data being processed.
Result equals process parsed.
Calls the process function with the parsed variable as its argument and assigns the returned value to a new variable named result. The line demonstrates a straightforward function invocation where parsed serves as input and the output is captured in result for potential later use.
Return result.
Returns the value stored in the variable result to the caller, terminating execution of the current function. FastMCP2's OpenTelemetry integration lets you layer custom instrumentation atop automatic tool tracing. The pattern here uses context managers to create nested spans that maintain parent-child relationships while capturing operation-specific metrics. By calling getTracer within the @MCP tool-decorated function, you access the same tracing infrastructure that handles automatic tool registration, then explicitly instrument sub-operations like parsing and processing. Each span gets relevant attributes, input length and data count, that provide granular observability beyond what FastMCP tracks automatically. The trade-off is clear. You add some code complexity to gain precise visibility into internal operation timing and data characteristics. This approach is particularly valuable for debugging complex tools where understanding sub-operation behavior matters more than the overhead of manual instrumentation. The key insight is that custom spans complement rather than replace FastMCP's automatic tracing, giving you control where it counts while maintaining the framework's built-in observability benefits.
The tracer sleeps through success, but wakes screaming in failure, scribbling its name in red.